viewers, welcome to CEC lectures. Myself Dr. Preeti Chugmani from Department of Computer Science, Aryabhat College, University of Delhi. In the series of database management system, we have seen introduction to database management system, and we have also covered some more some deeper fundamentals, and we will be covering some other aspects of database management system in this lecture. So now let us try to see a very important term here is about which is the database schema and the database instances. So in order to understand this database schema and instances, let us try to take an example. So when we talk about any programming language or something of that sort, we use variables. So variables basically variables are having their own declarations along with their associated type definitions, and then a variable is going to have a particular value at a particular point of time, and then this value is going to be change at one point of time. This integer a, let's say, is having a value of 10. At another point of time, that integer a maybe is having a value 11. So when we talk about the variable declarations along with the associated type definitions, they are in in analogy with database, they corresponds to schema, and when we talk about the particular value of a variable at a given instance, they talk about at a particular point that this is actually the instance of the database. So instance and schema, when we say that, here database is having a overall design, a specific structure. That overall design of the database is known as database schema, and these database schema are not going to change very frequently. Changes, if at all are going to be there, they are going to be very infrequent changes. While we talk about when we talk about instances says at a particular point of time what is the status of the database. So for example, let us say a database which is instructor, the database file is named as instructor, that means it is having the data of all instructors. So at a particular point of time, let us say that instructor database is having 4 values within it, or the data of 4 instructor. So that is one particular instance of the database. At another point of time, 2 more instructors have been added. So 2 more records have been added, and now your database is having 6 records or 6 schemas, 6 instructors. So that is another instance of the database. So basically, when databases are going to be changed over the time in terms of information when it is inserted or deleted, that collection of information stored in the database at a particular moment is called instance of the database. While when we talk about overall design as in I am talking about, let us say, this instructor. So this instructor, the overall design is having 4 pieces of information which we called as field. So 4 fields for this instructor: ID, then name, then department name, and salary. This is what the overall design or the structure of that particular database file is. So that is what you called database schema, while the information which is stored inside the database at a particular moment is called the instance of the database. So database systems may have several schemas which are pertaining to various levels of abstraction. As we have seen, there are levels of abstractions, there are levels of there are views of data which are physical level, then logical level and view level. So pertaining to those 3 levels of abstraction, database systems may have several schemas. Now let us try to understand this term, why this database is having several schemas. The physical schemas describes the database design at the physical level. So physical level, how that data is stored, that overall design structure is being described by physical schema, we can say. while the logical schema describes the database design at the logical level. And also we have seen view level, which is your database is having several views within that view level and the design of those views. So, for example, as in the previous lecture we were studying this view level, and I have told you that for admin department salary is not of a concern. So, admin department, or maybe security, for security purposes, admin department is not allowed to access that particular information which is about the salary of the instructor. So, a different view of the instructor is given to the admin department, which comprises of only ID, name and the department name, but not the salary. So, that is one of the sub schema that is going to define the different view of the database. Now, as we have seen in the previous lecture that physical or physical level is lying beneath the logical level. Physical schema is actually hidden from the logical schema and can be changed easily without affecting the application program. Now, application program here is the program which is written in order to access or modify that data. So, without affecting that particular application program, it is a good idea that physical schema can be changed and it should not affect the application program. So, that means with whatever change in physical schema is there, it should not trigger a change in the application program. So, here also we can see that logical schema is the most important in terms of its effect on application programs, since these application programs are constructed by the programmers using the logical schema, but physical schema should not have this effect on the application programs. So, these application programs, or in turn your database management system is said to have physical data independence if they do not depend on the physical schema. So, if your application programs are actually independent of any changes in physical schema, we can say that your application programs are exhibiting physical data independence, and with every change in physical schema, there is no need to write, there is no need to rewrite, or there is no need to change the application program, we can say. So, instances is schema, we have seen that these are analogous to the type of information variable in a program, and logical schema is all about overall logical structure of the database. So, in terms of database of a bank, the database consists of information about a set of customers and accounts in a bank and the relationship between them. So, we have several instances, we have schemas at different levels. We have physical schema, we have logical schema, and we also have sub schemas which are available at the, we can say, at view level. Physical schema is all about the overall physical structure of the database, while your instance is the actual content of the database at a particular point in time. Now, when we talk about the term data independence, we have different type of data independence. One is called as physical data independence, another one is called as logical data independence. So, considering physical data independence, we need to have, which is, we can say, ability to modify the physical schema without changing the logical one is your physical data independence, and ability to change application programs without changing the logical schema is about logical, we can say logical data independence. So, basically we can say the interfaces between the various levels and components should be so well defined that the changes in some parts do not seriously influence other. That means changes at one level of abstraction should not affect the changes at another level of should not affect whatever is being implemented at different level of abstraction, different level of abstraction. So, we have seen the views of data. We have also seen the different levels of abstraction, and we have also seen the concept of instances and schemas. So, with this let us begin a new subtopic which is about the data models. So, when we talk about the term data model, we can say underlying the structure of a database there is a data model, which is actually a collection of conceptual tools for describing the data, for describing the data relationships, for describing the data semantics, and also describing the consistency constraints. And a data model is something which is going to provide a way to describe the design of a database at all the levels, or all the levels means we have physical level, we have logical level, we have view level, and data model is something which is going to give us a way at the design, which is going to give us a way to describe the design of the database at various levels, we can say. And data models, if we talk about, we can have 4 different categories of data models. These different categories of data models are: one is the relational model, another one is the entity relationship data model, which is known as ER model in short, which is stored mainly for, or which is mainly for database design. Then we have another one which is object based data models. This is kind of a relationship between object oriented and object relational data model. We will be taking it in a in a short while. And also we have semi structured data model as an extensible markup language, which is the XML. So, all these are actually data models. One is the relational data model, another one is the data model which is at the level of database design, which is for database design, we can say entity relationship model, which is the ER model. Then we have object based data models, and we have semi structured data models as we have an XML. Apart from this 4 categories, we also have some older models, which are the network model and the hierarchical model. These are actually, we can say, the older models. Now, let us try to explore briefly all these models: relational, ER model, object based, and semi structured data models. We are going to cover these models in a kind of say in a very detailed manner, but let us in this lecture let us try to explore the brief, let us try to understand about them actually what they are. So, relational model, when we talk about, it is something, as I have told you, that model is something which is going to represent the whole design of the data. Now, relational model, when we talk about, it uses a collection of tables to represent the data and the relationship among this data. So, whether there is a data or there is a relationship among the data, both the things are, or both the entities are represented with the help of a table. Now, what actually a table is, we can say table is nothing but a combination of rows and columns. It can have multiple columns and multiple rows as well, and each column is having a unique name, and these tables are also known as relations, and that is why this is the representation of data and associated relationships with the help of tables is known as relational data model, and it is actually a record based model. So, when we talk about a record based model, the record based models are so named because the database is structured in the form of fixed format records of several types, and each table contains record of a particular type. So, for example, the table is of instructor, then this is going to have the records of type instructor only, and each record type defines a fixed number of fields or attribute. So, let us try to understand all these concepts with the help of an example which is available on the screen. So, here we have an instructor table. So, table, as you can see, it is in the form of maybe we can say combinations. We have columns and rows. So, it is having 4 columns, one is ID, another one is name, third one is department name, and fourth one is salary. So, each and every column is having a unique name. Now, one particular record which is ID number 22222, name is Einstein, department name is physics, and salary is 95,000. This particular information about one instructor whose name is Einstein, whose ID is 2222 and 2, he belongs to department of physics and his salary is 95,000. This particular information about an instructor is named as a record, and here you can say the table is having 4 columns, while there are various records which are having information about the instructors, and this particular table is containing the information only about the instructors. So, that means one fixed type of entity is being represented by the table. So, that is why, and this one particular information about an instructor here is known as one record. So, as I was telling you that each record type defines a fixed number of fields, or we can say fixed number of attributes. So, fields are also called attributes, and these records are also named as rows, or we can say tuples, and each table contains the records of a particular type, as we have seen that the table instructor is containing the records only of the instructors. While if we talk about the columns of the table correspond to the attributes of the record type. The relational model is one of the most widely used model, and majority of the current database systems are operating on the basis of relational model. And here when we talk about a relational database, we can say that in a simple language we can say that it's a collection of tables. So, here we can see a sample relational database. It is having 2 tables. Here we have shown only 2 tables, but it can have multiple tables. One is the instructor table and another one is the department table. So, collection of more such tables is going to define one database here. So, database actually a collection of tables, actually a collection of, we can say, rows and columns, where rows are fixed, having fixed format, which is we can call it as records also, and these fields which are vertical columns can be called as attributes also. So, here the instructor is having 4 attributes, 4 fields. One is ID, another one is name, third one is department name, and fourth one is salary. Similarly, the department table is having 3 fields or 3 attributes. One is the department name, another one is the building in which that department is being hosted, and the third one is the budget of that particular department. So, here as you can see on the screen, we can have multiple tables of these types, and collection of these tables is going to make up a relational database. So, this is what we can say a brief introduction to the relational model, or how this data is being stored inside the relational model. Apart from the relational model, the second model which we have seen in the 4 categories of database management system models or data models, we can say, one was entity relationship model, and in short it is known as ER model. So, this ER model is going to use a collection of basic objects called entities and the relationship among these objects. So, for example, let us say we have instructor is an entity, also we have department is also an entity, and there are attributes about these entities through which these objects or these things, we can say, in the real world are distinguishable from other objects. So, each entity is having some features, some properties, and on the basis of those properties we can differentiate that entity from other entities available in the real world. So, any object or anything that exists is we can say as an entity, and a relationship model which is going to be used for the or a data model which is going to be used for the database design. It is having two types of collections, we can say. One is the basic objects which are entities, and another one is the relationship among these objects. That is why this model is known as entity relationship model. And yes, we are going to use this entity relationship model in kind of, we can say, a large detail in our upcoming lectures. Now, when we say that these are used for database design, so at the design level we have logical design, as we have seen in the views. So, there is this logical design has to be very good in terms of what is the relationship between schemas. So, for example, we have a business decision, what attributes are we going to record in the instructor database. So, that is kind of a we can say design decision, and if we can say, or that is kind of a we can say a business decision. Corresponding to that, if we can see a decision which is to be implemented at the system level, would be what relation schema should we have and how should the attributes be distributed among the various relation schemas. What all schemas we are going to have, how are we going to distribute the various we can say attributes among those schemas. So, this is what the question of database designs, whether it is a business question or it is a question in the sense of implementation. For this, all these design decisions, we are in the need of your ER approaches, because the goal of the design is to come up with a methodology to ensure that each of the relations in the database is good. Now, for this can be either done with the entity relationship model, or this can be done with the normalization theory, and both of these topics, entity relationship model and normalization theory, we will be covering in our upcoming lectures. Coming to the second hour, which is object based data models. So, object oriented programming are actually dominant if we talk about software development methodology, and because of this dominance there comes the development of object oriented data model, which is actually we can say a combination of the features of object oriented data model and relational model. So, object oriented data model is also there. Apart from that, we have some data models like semi structured data model, which permits the specification of data on their own, where individual data items of the same type may have different set of attributes. In relational model, individual data types, individual data items of the same type. So, for example, instructor 1 Einstein and instructor 2, let us say Newton, both are having same set of attributes, but in semi structured data models we can have different attributes for different data items under the same uh, type that is permitted. And the example of this semi structured data model is your XML, which is extensible markup language, which is widely used to represent this semi structured data. Apart from that, lastly we also have network data model and hierarchical data model, which were used earlier before the we can say before the outset of relational data model. So, in this lecture we have seen what all data models are available. We have also seen instances and schema, and these basics were actually covered in this lecture. Here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed. Take care, goodbye. I will see you in the next lecture. Thank you.